get into our second one. Try and keep this one short. We're going to talk about continuous from the left and the right, but I got to introduce a function for you first. It's called the step function. We use it a lot in calculus. It just helps us show a little point. So here we go, step function, or the proper term for it. We're going to say, let's call it g of x is equal to, and the way we write it, it's kind of funky. It's called the greatest integer function. Or a step function. And we're going to play the game. So here we go. X equals 1.2. So g of 1.2 equals 1. Okay. X equals 7.9. G of 7.9 is equal to 7. The game is, all right, here we go. The input, 13.4. The answer is 13. 100.367. It's 100. Just get rid of the frickin' decimal. Just go down to the greatest integer below it. 0.1 is your input. The answer is 0. There's the greatest integer function. Just get rid of the damn fraction. You do this. It's not rounding. It's just get rid of the damn decimal and go down to the greatest integer. And here is how it's graphed. It's a step function. Right? So if you had 0.5, you'd be like, is your input? You're like, no, the output's 0. The height is 0. If you had 1.5, you'd be like, boom, we go up to 1. 2.5, just go to 2, and so forth. It's a step function. Look, it's like little steps. You can just step right up. And it goes on forever. Cool. But if you notice on the left-hand side of each one of those little steps, it's closed in saying that we actually obtain a value there. But on the right-hand side of all of those steps, we have an open hole saying that it is not the functional value there. Okay, now here's our definition. A function is continuous from the right at a number a if the limit as x tends towards a from the right-hand side is equal to the functional value. Okay? And then it's continuous from the left if we go from the left and it equals our functional value. It's not actually continuous there, it's just a new term. It's not actually continuous, but it's just the way we discuss this, and you're going to need to be able to do a couple of these in your homework. All right. So let's look, is this continuous from the left or continuous from the right at all of our integer values? If we come in from the right, we actually point. Now remember, you're not going to the right, you're coming from the right. So as you come from the right, actually traveling left, that's that positive one, boom, we can say that we are actually continuous everywhere. But continuous from the left? Oh, heck no. We're pointing at this, so we are not continuous from the left at any integer value, but we are continuous from the right at all values. Kind of weird, but there's our step function. All right, let's take a look. Let's go to another one. So I made up a fun-filled thing, and we go, all right. Let's see, are we, and I'm going to use this. Oh, continuous, I forgot. CTS. Nobody likes writing the word continuous. Us math people simplify it down to CTS. So, is it continuous from left at x equals a? Oops. From the right at x equals a? What's up? Let's look at a. A's right here. We don't care what the numbers are. At a. Is it continuous from the left? Is there a hole there? Yep. No, it's not. Continuous from the right. Let's go towards it. Is there a hole there? Nope. Then nope, it's not continuous. All right. Cool. Let's go to our next one. Let's go up here. Like out of order. Continuous from left at x equals b. Continuous from the right at x equals b. Let's look. We're like, well, from the left, hey, it points to a closed dot. Yes. Yes, it freaking is. Continuous from the right? Absolutely not. No, because it doesn't, it's a hole. It doesn't equal the functional value. Now I hope you can see. I'm just going to speak it now. Continuous from the left at C. No, because it goes towards a frickin' hole. It's pointing towards a hole. Continuous from the right? Abso-freaking-lutely. This is going to be some of your homework problems, so make sure you can handle these. Just a quick little thing. I don't like to go into too much depth with it, but there it be. Go get it. I'll see you.